I didn't. Everyone say hi to Abby.
Hi, Abby.
All right. We're going to start and get through this as well. So first step, we need to give you guys some reminders about how to solve equations in all this. So stay focused, please. We have lots and lots of ways to solve equations. So old system. The old system was that we would actually do the whole wraparound thingy, which sounds bad and wrong in a few ways. In the old system, and I would say log base 2 of 60 equals 3x. Problem with that. Taking derivatives of log bases other than e is something we're going to work on today, but it's just not fun or good. The other thing is that in big math higher than what you're in right now, the standard logs and the standard exponentials are all base e, everything. Everything is base e. So we're going to do techniques that solve everything with base e. So I'm going to go back and kind of axe that out, and we're just going to take the natural log of the left side and the right side. I'm going to do that to the left side. ln of 2 to the 3x equals the natural log of 60. And then I'm going to move the 3x out in front because of the log properties. 3x ln of 2 equals the ln of 60. And then I'm going to divide by the coefficient of x here, which if you kind of look at that x trapped inside of 3 and an ln of 2, can I just divide by 3 ln of 2 to get rid of that? I get x is equal to the natural log of 60 over 3 times the natural log of 2. Now, all that matters is that you are in a calculator-ready mode, where if you were using a scientific calculator, you could do this. You're not using a scientific calculator. You're using a calculator that is much more complex and much better than the scientific calculator. But if you were using one, you could do this. So I'm going to bring this up, and we're just going to try this. And sorry, Abby, this is like a trial for me. So we're going to do 3. I totally forgot what it was. 3 ln of 2. Thank you. ln of 60 over 3 times ln of 2. And it gives me that because this is the fun calculator. That's the CAS version. That's actually the most simplified form. For this one, I have to like Control Enter. But that's exactly what you guys should technically have. The 1.9689. Okay. So it says round to 3 decimal places. We're going to put 1.969. Really? So we get approximately 1.969. Okay, next one. You have options on this. We're going to take the natural log of the left side and the right side because I want to do that. But do we divide by the 5 first? Do we divide by it later? Does it matter? Let's not do that and just show how you can use your log properties anyway. If I take the natural log of the left side, what can I do to break apart that 5 and the addition? This is the ln of 5 plus the ln of 3 to the x minus 1. Be careful. Be really, really, really careful. I did not distribute that across addition. In fact, I'm going to be better than I just was. I'm going to show the first step that this is ln of 5 times 3 to the x minus 1 equals the ln of 74. And then I'm going to split it up into the ln of 5 plus the ln of 3 to the x minus 1 equals the ln of 74. Remember, the ln of AB is the ln of A plus the ln of B. But the ln of A plus B is not the ln of A plus the ln of B. Be really careful with that. Same with subtraction. Replace multiply with divide, replace plus with minus, and those same properties or not properties hold true. Okay, next I could subtract the 5 over, and could we do 2 things at once? Can I subtract the ln of 5 to the right side and also bring the x minus 1 out in front of the ln of 3? So I get the ln of 74 minus the ln of 5. And think back to the first step. If you had divided both sides by 5, you would have the same right side. Just it would be written as the ln of 74 fifths. Doesn't matter either way. I'm going to divide by the ln of 3, and I'm going to add 1. So I'm going to divide by the ln of 3, which gives me the ln of 74 minus the ln of 5 over the ln of 3 plus 1. And you have to ask yourself, is that in calculator-ready mode? Yes, natural logs are calculator-ready, meaning any calculator scientific on the planet will be able to do them. Your calculators, when they are in testing mode, cannot do logs or natural logs of bases other than e or 10. You guys actually learned that a couple years ago. And the same thing's going to hold true. We're going to put you in testing mode and restrict it, and you guys are going to be held to logs of a basis e, and that's it. In fact, we're not going to use base 10 at all, ever. I know that's shocking, but we won't. Okay. Again, I'll try to see if I can quickly switch to this so I can show the calculator. We're going to type this in. Since it's off screen, I have like the memory of a gnat right now. What was it? ln of
74 minus ln of 5 over ln.
Okay. You guys know also when you're typing these things in, wasn't it +1?
Yeah.
To make sure that you're typing in exactly how you would see it. That's the best way to get a good result. If you do type it in and you press the control division symbol, that gives you the fraction bar. It's an interesting little app they built. It's the Inspire. It's like the same calculator you have, but they put it as an app style, and then they charge $30 for it. So
What's the water button?
the water button. I think these are chemistry symbols that are supposed to creep up. Actually, I don't know. The water button. I'd never really even noticed that. Okay. In any case, this is about 3.453. Okay. Watching time and trying to make sure we actually get to the calculus here. Let's fly through the next couple. Okay. So remember, your goal is calculator ready. And this is, if I write this as x minus 2 equals what?
5 to 7.1.
Yeah, 5 raised to the 7.1. And I get x is equal to 5 raised to the 7.1 plus 2. Most calculators are fine with that. We're going to skip the rounding part and just kind of keep moving on so we can fly to the next bit. Let's go to this. So this comes from equations that are all about growth or finances, especially compound interest, that kind of thing. If I want to isolate t, which usually stands for time, I can take the natural log of both sides. So if I take the natural log, I get ln of 1 plus 0.06 over 12 raised to the 9t equals the ln of 3. Bring the ln or that out to the front, so I have 9t times the ln of 1 plus 0.06 over 12 equals the ln of 3. And I get t is equal to the ln of 3 over 9 times the natural log. And if you don't feel like simplifying the 1 plus 0.06 over 12, you don't have to. That is 6 over 1200, right? Which, I mean, why? If your goal is actually to get a calculator ready mode, you don't need to do much more thinking than's required. Every one of you could plug that in. In fact, that one I think I'm going to just practice plugging in for a second to make sure we get this going and looking good. So if you guys could, again, read that one to me. Oh, you're supposed to say, put a fraction bar in. Oh, I keep tapping. Okay, I was confused. I keep tapping this like I'm supposed to tap this iPad. I'm like, no, I got to touch the iPad. Okay, ln of 3 over 9 times the ln of 1 plus 0.06 over 12. Is that right? Okay, we get 24.475. By the way, Josh, if I press the H2O button, I get, I don't know, it's not doing anything. Okay, so 24.475. Okay, next, just more practice with conversions. Isn't this just equal to x is equal to 3 to the 4.5 plus 6? Can you guys do that in one step? Be helpful if you can. We'll just do that one here too. Come on. Did I drag it too far down? Nope, there we go. Come on, come back up here, iPad. 3 raised to the 4.5 plus 6. What? That was the correct thing you put in. 146.296. Thank you. So this is about 146.296. Okay. So let's get to the calculus of this. The goal today is actually to be able to do derivatives and integrals of logs and natural logs and exponentials of bases other than e. I am going to back up. This top is just kind of here for you. I'm looking at how much space you have. But do we have space on the front page at the bottom? Oh, I gave you a page? Sweet. This is going to be that page that you guys have. I want to do just a few things. So let's say that I have a base b raised to the x power. And I want to take its derivative. And I know that the derivative of e to the x is e to the x. What I need to do is I need to express b to the x as e to the x. And it's not as hard to do as you think it is. We need to use a couple of properties. One of them is this. I know that e to the ln of b is equal to b. That you guys should know. You should know that e to the natural log of b is equal to b. You should know that because, well, they're opposites of each other. Exponentiating with a base e and then taking the natural log are opposites. You also should know that the natural log of e to the b is equal to b. And those are two ways that you can substitute b in for. I'm actually going to write b on the left side now of several of these. Because what I'm going to do here is replace this b with e to the ln of b. And then raised to the x, because there was that x before. So do you see the substitution that I did? B became e to the ln of b. Now, what do you do when you raise a power to another power? What happens to the powers? Multiplied. So this becomes e to the x ln of b. And now I can take its derivative. The derivative of b to the x, if I take it based on this, what's the derivative of this right here? We've got to chain rule it. So what's the derivative of the exponent? Remember, ln of b is a constant. You got to do, no, just chain rule first. If this was e to the 2x, what would be the derivative? 2 e to the 2x, right? But this isn't 2x, it's ln of bx. In fact, maybe I'll write this like this, ln of b times x. So what's the chain rule derivative of just the exponent right here? What's the derivative of ln of bx? There you go, Simba. Guys, all I'm asking is, what's the derivative of this right here? Kara, not x over b. B is not a variable, it's a constant. It'd be like saying this. Let me kind of back up for a second. If I had e to the 2x, the derivative of that is 2e to the 2x, right? I don't want to say equals, so I should probably put a derivative thing. If I have e to the ln of 2x, the derivative of that would just be ln of 2 e to the ln of 2x, well, times. Because ln of 2 is just a constant. I not chain rule, but I do have to take the derivative of this. The derivative is just the ln of b times this whole thing over again, e to the ln of b x. I'm going to erase this because that was confusing. Just hang on, one at a time, guys. Go, Alex. Well, think about it this way. I mean, again, when I have e to the 3x, and I take its derivative, it's 3 e to the 3x. Well, the ln of b is a constant. It's not a variable. It's a constant value. So when I take the derivative of a constant times x, the derivative of a constant times x is just that constant. Okay. This can be simplified. E to the ln of bx. Remember, that's the same thing as this thing. So this is ln of b, b to the x. And this is about to become a lot simpler because we're going to do number 1 here, or number 6, and just show how this is going to work and what you really are going to end up doing. If I take y prime of this, what I'm really going to do is I'm going to take the derivative of the numerator, of the exponent. So the derivative of 2x is 2. Then I'm going to multiply this by the natural log of the base, ln of 7. And then I'm going to multiply that by the entire exponential again, 7 to the 2x minus 1. That's it. The derivative of an exponential is an exponential. The derivative of e to the x is e to the x. But if I take the derivative of b to the x, where are we with derivative of this? All right, here, look at this is the one right here. I shouldn't have written this out. We should have just handwritten it. The derivative of a to the x, where a is not e, is just the natural log of a times a to the x. Look at that version there. Simba.
So for number 6,
Yeah. The 2? How about, where'd the 2 come from, Simba? Why don't I show this one out as an actual example of how the long process works. And then we'll do this shortcut here in a second. So when I do this, I go y prime is, we're going to rewrite this as e to the ln of 7 raised to the 2x minus 1. And I'm going to rewrite that one, sorry, this is not even y prime, that's just y. I'm going to write that as e to the ln of 7 times 2x minus 1. And now, Simba, we're going to do the chain rule derivative of this. Okay? If I do the chain rule derivative, the derivative of the numerator of this thing, not the numerator, the exponent, is actually going to end up being 2 ln of 7. Because if I were to distribute the ln of 7 into the 2x minus 1, it'd be 2 ln of 7x minus ln of 7. The ln of 7 part would drop out. So we get that, then times e to the ln of 7 2x minus 1. Well, we just said that whole thing is really 7 to the 2x minus 1. So I get y prime equals 2 ln of 7 times 7 to the 2x minus 1. And we're going to skip a lot of that to make this go faster. But that's how this is going to play. So let's do like lots and lots of examples of this as you guys get used to this. Okay, number 7, we're going to do low d high. So low d high. D high is the derivative of 3 to the 2t. So 2 times ln of 3 times 3 to the 2t. Minus high, which is 3 to the 2t. D low is 1 over low low. And what I'm going to ask you to do is to factor out that numerator. Take the 3 to the 2t out. So get f prime of t equals 3 to the 2t times, we can write this as 2t ln of 3 minus 1 over t squared. Okay, next, we have a product rule with sine. G prime of alpha. You're like, why did you use alpha? First, derivative of the second. So 5 to the a over alpha over 2, not a. And not infinity symbol. 5 to the alpha over 2 times the derivative of sine of 2 alpha is, chain rule, 2 cosine 2 alpha plus second derivative of the first, so take the derivative of alpha over negative alpha over 2, so that is negative 1/2. Now take the natural log of the base, ln of 5, and then 5 negative alpha over 2. For those watching this video 5 years in the future, yes, that ringtone is still a thing in 2019. Okay, g prime of alpha, is we're going to pull out the 5 negative alpha over 2. I'm factoring out the 5, the exponential part. So I get 2 cosine of 2 alpha minus 1/2. Actually, we'll write it as minus ln of 5 over 2 sine 2 alpha, and I can leave that like that. Okay, next. 9, 10, 11 are a little bit different. And here's what I would recommend with them. You have a log base 2, and so you don't mess the derivatives up. We're going to use the change of base theorem to write these as natural logs. The change of base theorem says that if I have a log base 2, this is equal to the natural log of t squared plus 7 cubed divided by the natural log of 2. You guys did change of base a long time ago, or last year, when you were able to express logs of different bases as log base 10s or log base c's. You may remember them as this is how you enter it in your calculator. Whenever you guys would have something like the log base 7 of 2 and you have to enter it in your calculator, you type it in as the log of 2 over the log of 7 or log2 over log7. They were the same thing. But this is the same property. Because what is ln of 2 here? It's just a constant. So g prime of t is equal to 1 over ln of 2, and now I don't even have to deal with it. I'm pulling the whole thing out, and we just take the derivative how we always have. Chain rule. Work your way inside out. So the derivative of t squared plus 7. Oh, you caught me, and you caught that, and that is brilliant. Yes, you do. You're going to have such an easier time, and I totally missed that. Sammy, nice job. We want to write that as 3, because then our constant is 3 over ln of 2, and this is a lot easier. We do the derivative of the inside, 2t, times the derivative of the natural log of something, which is 1 over that same something. And if I clean this up, I get 6t over natural log of 2 times t squared plus 7.
Why don't you do high D low or low D high?
I don't do low d high because high d low is 0. The denominator is a constant. It's not a variable. It's the same reason why if I had t squared plus 7 over 2 and I was taking its derivative, don't do low d high, factor the 1/2 out. It's a lot easier. So Sammy, by that same logic, can I rewrite this before I actually do anything? This is 1/3 times, remember it's going to be the natural log of this over the natural log of 2. So I'm going to put the natural log of 2 in the denominator. And I have this times the natural log of 2x plus 1. Yep. This goes back to an old theorem that we don't have time to get completely into right now. But if I have the log base b of x, that is the same as the ln of x over the ln of b. That was called the change of base theorem. And it let you take bases that are b and change them to other bases. Okay, f prime of x equals, what's the chain rule derivative of the inside of here? 2. So I'm going to write this as 2 over 3 ln of 2 times 1 over 2x plus 1. And I would just leave it like that. That looks plenty pretty enough. Okay, so I'm just looking at where I am. G of x, let's rewrite this. Can we do a couple of things when you rewrite it? This is you guys have experience in splitting these things up. I've got to do one more little piece of that, and that's to pull out the 1 over ln of 5 so I can convert the other part into natural logs. Then we're going to do times ln of 4 minus what?
Minus the bottom.
Yeah, minus the bottom. What is the bottom? Minus 2 ln of x minus 1/2 ln of 1 minus x. See how the powers of the logs make this a lot easier? What? It's minus because it's in the denominator. It's a negative distributed. Think about this as being minus with that being a plus, and then I'm distributing the negative. Right, Corinne? Okay, so we get all this thing, and then let's go g prime of x. Pull that out. What's the derivative of ln of 4? 0. Constant. Minus 2 over x for this. Minus 1 over 2 times 1 minus x. I'd like to spend a moment and just clean some of this up a little bit. Where'd I get the what? Oh, I forgot that. Thank you. I'm messing up royally today. I forgot the chain rule derivative of this, didn't I? And that would be a -1, so that comes out as a positive right there. So my cleanup step, if I can just kind of finish this for a second, what I'm going to do is actually factor a negative out and make this -1 over ln of 5. Make this 2 over x. And if I pull the negative out, this is going to be plus 1 over 2 times x minus 1. I switched the order of the x minus 1 so I could pull a negative out. Just makes it cleaner. This was plus right here. When I pull the negative out, it becomes a minus, but then when I switch this from a 1 minus x to an x minus 1, it becomes a positive again. Like when I write it like this. Okay. Well, it was a good effort. We are going to have to split this into 2 parts. So tomorrow will be partial workday, partial note. Wait, was that the end of the notes?
Yeah.
Oh, sweet. Okay, then no, it wasn't. But this you guys should be fine with tonight because it was always split into 2 parts.